Now we're going to talk about the derivatives of the natural exponential function. Now these derivatives can be some of the easiest derivatives you'll do all semester, but with that they could also be the easiest to mess up. So be very careful with these. The derivative with respect to x of e to the x is equal to e to the x. And that's all there is to it. You don't have to do anything else special with that. I'm not going to bore you with the details of why this is true. If you're interested in it, you would probably want to take a real analysis class because that's where you would delve into that kind of proof. But it is. I like to think of e as a very egotistical derivative. It's very egotistical. It is its own derivative. So the derivative with respect to x of e to the u, however, if u is a function of x, is e to the u times du over dx, or you might see this written as u prime e to the u. So if I want to find the derivative of something like e to the 2x minus 4, I would let u be equal to 2x minus 4. So this is the derivative with respect to x of e to the u, which we know is u prime e to the u. U prime is 2, so this is going to be 2e to the 2x minus 4. And that is my answer. Notice the exponent didn't change. A lot of students have the tendency to want to take the derivative of the exponent, but the derivative of the exponent goes out front. The exponent itself stays the same. So for this example, I have the derivative with respect to x of e to the negative 2 over x. So this is also going to be the derivative with respect to x of e to the u, where u is negative 2 over x, or negative 2x to the negative first power. We are going to need the u prime because that's u prime e to the u. So u prime here is going to be negative 2 times negative 1 x to the negative 2, or 2 over x squared. So this derivative ends up being 2 over x squared times e to the negative 2 over x. Now if you thought this might have been the natural log, you're thinking of the integration. The integral of 1 over x is the natural log of x, not the derivative. Now in this one, we're going to have to use the product rule because we have x times e to the x. So if I let f be equal to x, then f prime would be 1. If I let g be equal to e to the x, g prime, the derivative of e to the x, is just e to the x. So this derivative is going to be fg prime plus gf prime, which is x e to the x plus e to the x times 1, or just x e to the x plus e to the x. Now this is a perfectly valid answer. I wouldn't have a problem with that, but a lot of people like to factor things, so you may see it written as e to the x times x plus 1. Equally valid. No reason I wouldn't accept either one of those. Now with this one, you've got two options. You could use the quotient rule, which is what most of you will probably do because it's what you see first. So we would let, we know that this would end up being gf prime minus fg prime over g squared, where f is x, so f prime is 1. G is e to the x, so g prime is e to the x. So this would be e to the x times 1 minus x times e to the x all over e to the x squared. And in this case, I would want to go ahead and factor the e to the x because it allows me to cancel 1 here. So that would be my final answer there. The other option is we could write this as the derivative with respect to x of x times e to the negative x. Remember, if you bring an exponent up across that line, you have to change the sign of the exponent. So in this case, we could use the product rule. So this would be fg prime plus gf prime. Now, f in this case would be x, so f prime would be 1. G would be e to the negative x. So this is e to the u. So g prime is u prime e to the u. U is negative x, so u prime is negative 1. So this would be negative e to the negative x. So this right here would be x times negative e to the negative x plus e to the negative x times 1, Or if I factor out the e to the negative x, I would have negative x plus 1. And I could write that as negative x plus 1 over e to the x by bringing that down. So you can see that you do get the same answer in both of these problems.